Hi there, Mr. Ray here, and we are going to do another topic. The difference of squares, okay? The difference of squares. But first of all, what is the difference of squares? Is it looking at two different squares and finding out how they're different? One is big and one is small? No, it has to do with quadratics. And a quadratic is an x squared plus other terms. Okay, well, let's take a look. What we have here is we have four expressions, not equations, expressions. And so what we have, the first one, x squared minus 12x minus 4, is that a quadratic? Yes, it's an x squared. That's a quadratic. How about x to the third minus 27? No, that's a cubic, not even a quadratic. X plus 1, that's linear, not quadratic. X squared minus 4, that is a quadratic. Now, between the two, let's say 1 and 2, which one is a difference of squares? Now, a difference of squares means something squared minus something squared. So a squared minus b squared is equal to a plus b times a minus b. Something squared minus something squared is equal to the first power of that plus the first power times the first power minus the first power. Two binomial expressions in parentheses. Let's take a look at that example. When we have x minus x squared minus 4, we can think of that as two terms squared. X is squared, 2 is squared. You can think about that as x is squared and 2 is squared. And we can use that formula right above. That means it's going to be x plus 2 times x minus 2. Can you write that in the reverse order? Sure. X minus 2 times x plus 2. Okay? Now we're going to go on to some easy examples, and then we're going to go on to some more complicated examples. I know in the last video I said I was going to factor quadratic trinomials when a is not equal to 1. That will be in the next video. But right now, let's focus on the difference of squares. Okay, we have another one, x squared minus 25. Is it a term squared minus a term squared? Yeah, x is squared. And what is squared to give us 25? 5. And by the way, it's very good to know what your squares are. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I'm going to do these quickly. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and 10 squared is equal to 100. Now, what's interesting about this, if you noticed before, is that the reason I wrote these out is that when you go from one to the next, you add an odd number. You add 3 to go from 1 to 4. You add 5 to go to 4 to 5. You add 7 to go from 9 to 16, and so forth. Take a look right here. 81 to 100, yeah, you're going to add 19. So you can know the next one. You're going to add the next odd number, which is 21. And the next one, 11 squared, is equal to 121. 12 squared is equal to 144. And I'd say you really need to know up to 12 squared. Okay, well, let's take a look at this one right here. Going back. Okay, so what we have here is we're going to use the same formula. A squared minus b squared is equal to a plus b times a minus b. And so what we have is we have x plus 5 times x minus 5. You can write it in a different order. X minus 5 times x plus 5. Okay? Okay, but what if a is not equal to 1, right? Because these are quadratics after all. They are quadratics, and every quadratic is ax squared plus bx plus c. And if you have x squared minus 25, you know that you must have an a, b, and a c. A is equal to 1. b is equal to, well, c is equal to negative 25. So b is equal to here 0. Difference of squares is when b is equal to 0. But what if a is greater than 1? So for example, a is greater than 1 here, right? A is 4, b is 0, c is negative 9. And we have a difference of squares. We want to look at the 4x squared and say, what was squared? Well, what was squared here is a 2x. What was squared here? That was a 3. Square and square, square and square. The difference between the two squares. So then we have 2x plus 3 times 2x minus 3. Can also be 2x minus 3 times 2x plus 3. Okay? And we're doing pretty good. But let me give you one that's a little bit more complicated with bigger numbers and 2 variables. Okay, so what do we have here? Well, we have 2 terms squared. We know that we have here, and I'm going to do the blue color, we have a 7 that was squared. We know that we have an 8 that was squared. We know that. X was also squared. Y was squared here. We're going to put the parentheses around this one, put the parentheses around this one, put a negative in between, and use the same formula. 7x plus 8y times 7x minus 8y. Okay? Now, we're doing pretty good. But the next problem I want to show you is not a quadratic, but it's some type of problem a lot of students have to do in algebra. So let's take a look at a more complicated problem. Okay, we have 144a to the 6th minus 121b to the 8th. How would we do this? Okay, first of all, we can recognize the squares, 144 and 121. You should be able to know that right away. That's 12 squared and that's 11. It was 12 that was squared and that was 11 that was squared. But what about these even powers? Well, if they're even powers, the 6th and the 8th, they are a term squared. If the powers are even, it was a term squared. So in that case, it's a to the 6th divided by 2. That's what was squared. That's a to the 3rd. In other words, a to the 3rd times a to the 3rd is a to the 6th. And that b to the 8th was a term squared if we divide it by 2. That was b to the 4th. That was squared. Okay? So b to the 4th times b to the 4th is equal to b to the 8th. So we can put an a to the 3rd, that's what was squared, and a b to the 4th right here. Put the parentheses around them, put the parentheses around them, put a negative in between, and use the same formula. Plus 12a to the 3rd plus 11b to the 4th times 12a to the 3rd minus 11b to the 4th. It's a long problem, and it's more complicated than ones we did before, but some of you have had issues. Students, I've noticed, have had issues with this type of problem a lot, so I wanted to throw that in there. Okay, next, I'm going to give you a couple problems that you could try, and then we can do them together, okay? Hey, so welcome back. We have x squared minus 49, 36x squared minus 1, 2 expressions. Go ahead and factor these, and then come back to the video. Okay, so I'm going to say it again. Welcome back. And what do we have for number 1? Well, we know we have an x squared, x that was squared, and a 7 that was squared. So I'm going to write that. X that was squared minus a 7 that was squared, and that's going to give me x plus 7 times x minus 7, or x minus 7 times x plus 7. Okay, now the second problem, number 2. If you haven't tried this, go ahead and do so. But this second problem is a little bit different because there's a 1 there, and that always throws students off. 1 is 1 squared. I know that sounds simple, but for some reason, this throws students off. So 36x squared is 6x squared minus 1 that was squared. So this is 6x minus 1 times 6x plus 1, okay? Now, I'm going to put in a bonus problem, a bonus difficult problem. Oh boy. Yeah, not a quadratic. So let's take a look. First of all, you got to know your number squared. Is this a term that was squared? Yes. A number that was squared? Yes. 8. How about 81? Yeah, there's a 9. Okay, are the powers of, we have x to the 4th and we have y to the 10th. Are they even? Yes. So they were terms that were squared. What's squared to get x to the 4th? X squared. What was squared to get y to the 10th? We divided by 2. Divide 10 by 2. Y to the 5th. If you just divide the powers by 2, you see what was squared to get those powers. They're even powers, so they must be terms that were squared. So we have 8x squared minus 9y to the 5th times 8x squared plus 9y to the 5th. That's the bonus problem. A little bit difficult, I know, but students do run into these type of problems. Okay, so in the next video, we are going to do trinomials again, like I did in my first video. So the next video is going to be problems just like this. 12x squared plus 17x plus 9. This is when a is greater than 1. Trinomial when a is greater than 1. This is a trinomial. So if you're having a good time with these videos, you're learning something, please hit that like button, subscribe. The next video will be when we're going to factor trinomials again when a is greater than 1, when that a is not 1. And I have an easier approach, a fast approach to it, which might be a little bit different than what you've seen before. So go ahead and take a look at that, and I'll see you next time. I'm going to look